All right, we have the second example. We're still looking at determining the gradient at a point using differentiation. So we've been given this quadratic function, x squared minus 3x plus 5. But find the gradient at the point x equals -1 and the point x equals 1. So the first thing that we need to do is we need to derive this function. So we're going to start with x squared. So using the power rule of differentiation, get the exponent. This is 2 multiplied by the coefficient. Coefficient here is 1. So 2 times 1, that is 2. We have x here. Then we subtract the 1 from the exponent. 2 minus 1 remain with x to the power 1. Minus, we have 3x here. 3x to the power 1. So we get the exponent multiplied by the coefficient. 1 times 3, that is 3. Subtract 1 from the exponent. 1 minus 1, that is 0. So we have 3x to the power 0. And as I said, from the rules of indices, anything to the power 0 is the same as 1. So this x to the power 0 becomes 1. 1 times 3, that is 3. Right? Then 5 hasn't got any variable attached to it, so it disappears. So we've derived our quadratic function, and you can see what we've got now is a linear expression. So the next thing to do, we need to find the gradient at the point x equals -1 and x equals 1. So the first thing that we're going to do, find the gradient at the point where x equals -1, is we're going to substitute x for -1 in the linear expression. So 2x, so 2 at the x, and the x we substitute it for -1. So 2 times -1 minus 3. 2 times -1, that is -2. -2 minus -3, that is -5. Right? So that is the gradient at the point for x equals -1. The next thing we need to do, we get the gradient at the point where x equals 1. So 2 open brackets, we substitute x for 1. Minus 3. Right, so 2 times 1, that is 2. 2 minus 3, that is -1. So that is the gradient at the point x equals 1.